What is up, YouTubers? So I'm still a little bit on the mend from being sick, and I thought, well, rather than carrying some heavy-ass steel into the shop and cutting it and listening to the obnoxiously loud saw, etc., I would take it a little bit easier on myself and do a more simple video. But this is simple only in the amount of physical effort it takes. It's going to be a pretty interesting video, I think. And what we're going to cover today is this sort of Facebook Marketplace post that's making rounds around the internet. And it is of a guy who is selling like do-it-yourself or a kit that his homemade kit that he welded together, vehicle lift. And the consensus is out. A lot of people see some very sketchy things in this, and I thought it would be a great topic to talk about, I guess, safety and weld strength, and do a lot of book theory, but make it at least interesting enough to where hopefully you stick around for the whole video. So that's what we're going to tackle today. Let's get into it. So I'm going to talk a little bit while I put these pictures up that are on the internet, on Facebook. But I saw this on I See You Don't Know Shit About Welding, where I'm a member on there, and I post occasionally, mainly to try and help people out, but that's besides the point. This came to my attention today, and then within minutes of it getting posted, people sent it to me in messages and stuff, and I got tagged in it, and I'm like, oh yeah, I can see why I was involved in that, because it's pretty borderline, I would say, unsafe what the guy has going on. And this is not going to be a video trashing the individual. I blurred his face out for that. Like, I have no interest in making fun out of people. I mean, I might make fun of myself, but other people, I don't have anything to gain in it, you know. But I will say that this project that this guy has going on is a great example of why you really need to think things through before you just go and build something, especially when there's liability. Now, we all know that certain things have higher liability. Like, if you're starting to learn to weld, do you think it would be smart for you to go weld on a drawbridge in a major city? No, let's be honest. But the problem can come up is when you know a little bit about welding, you might be a little bit overconfident and you might make something not realizing the danger of it. And you have to understand, guys, that welding is just one part of making stuff. There's also something called engineering. And engineering is equally as important as welding. Now, you don't have to have an engineering degree to go weld stuff in your garage and build stuff, and even like stuff that's going to last and do what it's designed to, okay? You don't have to, but if you don't have any idea of how loads work, how welds work, how to build something strong, why there's certain things done, if you don't have any concept of any of that, you can wind up like this guy and building some stuff that's borderline unsafe that could potentially hurt or kill you, or even worse, if you sell it like this guy apparently is trying to do, you could hurt someone else. And I don't want to see that happen to anyone, so that's why we're going to talk about all of this today. So to start things off, let's look at this little drawing I have on this whiteboard here. This is a replica of what this guy built, and I'm just going to finish drawing it there because I see that I didn't. So what we have here is a 4-post lift that this guy created to lift his vehicle off the ground. And I'm sure as you saw the pictures, you probably got a little bit of an uneasy feeling in your stomach, as did I. And that's a good thing. That's your spider sense to tell you something isn't right and you should probably fix it. The problem is based on what we saw there, we got to ask ourselves some questions. One, is it inadequately engineered? Possibly yes. 2, is it inadequately welded? Possibly yes. 3, is it safe to use? Possibly no. We'll discuss everything and we'll collectively come to an agreement on that, I think. And then 4, what has to be done to make it safe? And that's why we'll start out with this little drawing here. So this depicts what he has going on for his lift. Now there is a boat winch that he has mounted that goes up over the side of that and then hooks to itself. There must be a pulley at the top. And I will just kind of do that. He did have an additional brace initially in it. So the first thing I noticed right away is that in the first couple pictures of it, he had a brace that was on this outright arm, the lifting arm, that was not in the final product. And not only that, but that brace he had on there was welded pretty poorly. It was stitch welded, wasn't fully welded. That's a problem in itself. But his finished product, what he apparently is trying to sell, omitted this brace, okay, which is not a good thing. But based on the design that we see here, what are some serious flaws that we can detect? Well, again, one, he omitted a brace that would have made this tremendously stronger, okay? And the only weld that is holding this outright arm to the upright plate is a couple inch weld here, and presumably it's welded the width-wise here, okay? And then the same on the other side. Is that enough weld for the load that this arm is going to see? I would say yes, in the sense that that weld won't fail given the load on this, but the question is, what is the load on this arm? So he has 4 of these. If the car weighs, say, 2,700 pounds or 3,000 pounds, that isn't that much weight per arm. And realistically, I don't think that that weld is going to fail under the load of an average car. The problem is that you can't engineer things like this for lifting vehicles and not assume the worst case scenario, which is especially if you're trying to sell it to someone, that some idiot isn't going to put something grossly over its rating on it. You can't engineer something to the public that fails just above its rating. And well, in this case, it has no rating, but he had a fairly light car on it. Well, what's to say someone wouldn't put a 4-door wagon on it, some family sedan thing that weighs, 2,000 pounds more, and then have this whole mechanism fail? So it's not engineered for that. Now, again, this weld here probably won't fail. That's a good thing. However, the design of his arm is atrocious. And I'm not here to make fun of anyone, but it shows complete lack of understanding of engineering principles. And let me show you what I mean by that. I have a cardboard replica, it's not perfect, of that arm that he built, okay? The design of what he has there is extremely dangerous in the sense that this, because it's cut and it's open on the bottom just like this, will not actually handle that much weight. And not only is the material he's using, it appears to be not maybe 3/16, maybe even not that. It's really difficult. It definitely doesn't look like quarter. So what can happen is this thing is attached up here, right? Well, what is holding the side supports together? The answer is nothing based on the pictures. Well, what can happen as this is loaded and it's stressed? Watch what happens. Because nothing holds the sides together from either collapsing like this, or they could also collapse outward just like this. You wind up having whatever the strength of this flat material will resist before bending is the only thing that's holding it from basically collapsing. Had this had pieces of metal connected side to side to prevent this from coming out or coming in, the amount of weight that this would support would probably be 2 to 3 times as much versus just having it allow it basically to move at all. And if it started looking like this, like this is so weak, like this wouldn't even hold a quarter pound. If I were to hold this in place, it would hold tremendously amount more. So his major flaw in this whole design, and there's many, the weld here isn't going to be the problem. The problem is it's going to end up with enough load here is just going to bend right through here easily. So how could he fix that? Well, by plating the whole bottom side of it to prevent this from flexing in or out. That could help. By using square rectangle tube. I don't really understand the point of why he cut that unless he didn't have enough material to make it. But this would have been by far smarter to just use a piece of rectangle tubing. Okay, far stronger. The other issue with this, well, there's many, with this design is, depending on where the load is, will determine how much weight that this can handle. Ideally, if you're going to make something like this, you would want the weight to be as close to here as possible, because it's going to handle A, the most amount of load, and B, it's going to be the safest. Because not only for stability purposes, but the load essentially gets carried over here. When you're out here, the stress is going to be here to the tip. Okay. Another thing is the way that, well, he eliminated the bracing, and likely because he couldn't lift anything because the brace was in the way. And he probably figured, oh, well, this thing lifted the car high enough and hasn't failed yet, and the bracing was barely attached, so I'll just eliminate that. Well, if you look at any kind of reasonable lift, you're not going to find the weld right here and the weld on the side being used exclusively to hold something like this up. There's just not enough there. And that's where some form of bracing, whether or not it's at least a plate right here, or if it's a plate that comes down here all the way up to here, something needs to be done in order to support the load. And one of the things you guys are going to find, so you have a weld right here, right? And we'll use this. It would have been a fillet weld, and this is something that I bent in a previous video, okay? You can see how with enough force, and this is 3/8 steel, which he wasn't using anywhere near this, this whole arm could have bent down. It would still be attached, but that would be a catastrophic failure because you'd be wearing a car. Well, this weld happened to hold in this situation. It's possible that it wouldn't in real life, depending on what process you welded it with, but by simply putting this plate, you are now using the plate in tension rather than praying that this weld does and this steel doesn't flex here and here, okay? So the lack of bracing is a huge issue. Still though, even with bracing on it, likely what would happen is if there was an overload compared to what this could handle, here it may still, again, flex right here just like this cardboard. And so what? It didn't fail here. So that still, even with bracing here, this is still an issue. Again, had he designed a solid square or rectangle tube and a brace here that's back far enough to where it would not hit what he's lifting, this would be a by far better design. Now there's still yet more serious things that I noticed in the design of this, and that is, one of them is the grade 5 bolts that he's holding everything together. Now, will grade 5 bolts hold this together? Probably yes, but it's one of those things where why, when you have something with any kind of liability, would you choose grade 5 bolts over grade 8 when they're readily available? That makes no sense to me. You know, it's stupid in my opinion. So that is, again, a big no-go for me, is that this thing should have been held together with grade 8. So not only was the lack of grade 8 bolts something I really noticed, but the quality of the welds on this whole thing are extremely suspect at best. Okay, like on the bolt winch that he has, you can see it's held on with a couple boogered uphill welds, which, clearly his welding skill isn't that good. And I'm not trying to make fun of him, okay, but let's face it, his welding skill is not good enough to be welding on something with some liability like what he's making. So he probably should spend more time practicing and really dialing in his welds before he goes and tries to make something where the welds themselves are what's holding everything together. Like if you look at like highly engineered structures like bridges and stuff, like you want the material itself through engineering to hold most of the stress, not the weld. Because when you take a bar of steel that's uniform and complete, and you weld it together, well, where is a failure likely going to occur? Well, where it was welded together. And why is that? Because, well, that's the highest probability place that you would have a failure, because it's not a continuous piece. It's something that was put together, and in that can create the possibility of weld defects that reduce strength. So long story short, again, the quality of the welds are bad. The engineering is bad. I thought it was interesting that in a couple pictures, so what he has is he cranks this up to lift a vehicle, and he has holes that he puts safety pins in, which is fine. And he put like 3 safety pins in, but the reality is that if one safety pin breaks, they're all gonna break. So having multiple pins in isn't really making it safer in that sense. So that was kind of interesting to me. From the standpoint of engineering, there's a couple things I want to talk about. And that is the difference between shock loading or dynamic loading and static loading. And a lift like this, you might think, oh, well, it's just a static load. You just lift loads up and that's it. And the reality is that, well, yeah, when something's sitting on it, you have a static load. However, when you're cranking it up, that load will change as what you're lifting comes up based on your cranking. So you do have some dynamic loading. And not only that, what would happen if somebody, say, walked in your garage while that's on, a vehicle's on this lift, trips and pushes against it? Well, I can tell you that the arms that he has on there, again, these things, I don't think they're going to take too much of a push either way without flattening out and just having the car collapse on you. The other thing regarding that too that this guy probably did not think of is that when you're jacking a vehicle up on this, you have to go to 4 corners and keep cranking it. Well, what's to say that he doesn't get a little bit lazy and raises one side up, I don't know, 5 cranks too many, which offloads the weight off of 2 of the other pillars. So, like, I'll just draw a quick thing here. This is your car. And these are the lifters, okay? You sit here and you crank this bastard up 5, 6 cranks too many, and it offloads weight from here and puts more weight on this and this one. And next thing you know, they can't handle the weight and fail and the car collapses. So again, not a good design because it's very easy to overload one side of this more so than the other, very easily. Like even if you were to, okay, you lifted this one 3 inches, this one 3 inches, well now the car is tipped more on this side. So guess what'll fail? So you can't just say, oh, well, a car weighs 3,000 pounds. This only needs to handle 800 or something and it's fine. Well, yeah, but at any point, if it's offloaded a little bit, which due to the poor design is a high probability, what's going to happen? You're going to have a catastrophic failure. So again, I don't see, looking at all these pictures, in no way would I want to go under this. And I think that it's the probability of suffering catastrophic failure is extremely high with the design. And with a few simple changes, it could function, but before I'm going to actually give you guys an idea of how I would change it to make it work better. But my thought is, if you want to make something like this for yourself, have at it. If you want to attempt to make these and build them for someone else, you are really asking for something bad to come to you. And what I mean by that is a lawsuit. And from my aspect, which you guys got to remember, I've ran a side hustle welding business for years, and I've welded broken tow truck booms back together, which is something that the average person has no business even attempting. And arguably in the past one or time or two, I probably shouldn't have, but I got it done and did a decent job. But what I'm getting at is that it's one thing to make some super janky stuff for yourself. And well, I would hope you care enough about yourself that you would do a good job so you won't wind up in the hospital. But it's a totally different ballpark when you're trying to sell stuff like that to people, because people are stupid. And no offense to anyone. People, when they buy something, they think that it's good for whatever they can possibly put on it. And selling something like a lift without grossly engineering it and over-designing it for the average bear that's going to put something on it is just absolutely asking to wind up in a lawsuit, and even worse, seriously hurting someone. And that's why, like, this guy putting this up for sale, I'm pretty sure he's serious about it, is a huge mistake. And I don't think that and realistically, I don't think that the guy's going to sell it, but maybe he will, and I feel bad for whoever buys it. But enough about that. Let me show you how I would have engineered that if I was going to try and make something like that for better results. So my design may or may not be possible with the height of the car off the ground, but there's more than enough information here to make this work better than what was there. So the first thing that I would do is go to rectangle tube, like I had said, where it's closed on the bottom so that it doesn't have a tendency to pretzel, and drop it on you. The second thing is I would have welded a triangle or a truss from this, and it could even come all the way down here and go under it. Now, he had that reinforcement on the top because everything was here, and then he eliminated it. And it's without something like that, you're asking for catastrophic failure. And by putting it underneath it, you will basically be allowed to have it open here, and you won't have issues of putting something on it. You could lift closer to the beam while still having strength, okay? So that's a must. The other thing is not only would this be plated on the sides, but attached underneath it. So on this part, I would plate this part of the truss as well, just to put the load at this point down here. That way you're relying on essentially the strength here from collapsing and pushing. And I mean, this will never collapse here. So you only have load here in comparison to the design he had. So this is by far stronger and by far safer. From a realistic standpoint, this could probably handle 3 to 4 times the amount of weight that the guy's design could, and especially if you use reasonable thickness material. Like, to me, 1/4 inch minimum on this is what I would use. 1/4 inch would be a starting point, okay? Because again, you have to design it assuming lifespan and fatigue, assuming overloading, assuming possibility of dynamic loading, assuming misloading, all of that. And you're far better off making it too strong than just strong enough and having it fail. Okay, so that's a significant design change. The other thing is down here at the bottom where he had no braces at all, no triangulation, nothing, to where, again, everything is being suspended from bending and collapsing this together. Some form of a brace, either a side plate that it ties in or from here to there, something to prevent that from collapsing. Because again, you know, the liability on this is high enough that what's a couple pieces of metal and a little bit more welding to offload the weld strength here and here and put a plate to where it now has to bend that plate, okay? Another change, I don't know how thick this main square tube that he's using is. 3/16 wall would be what I would consider as a minimum, okay? But my thought is where he drilled holes through it and just put a pin, for the longevity of it, I would actually drill a hole, put a tube through it, weld the tube on the outside, and then to where that pin is going through the tube. In my experience with thinner wall, like tube, square tube, when you put a pin through it, it's going to waller out that hole pretty bad with weight over time. I've seen it with like engine lifts and stuff. And it's by far safer where a couple of the pins, you know, where it's at like lift height, it would be by far safer to do that, in my opinion. Now, if he used thick enough wall like quarter, I wouldn't worry about it as much. But with that paper thin wall he probably has, I wouldn't think that is going to cut it, and it's going to waller it out over time. Beyond that, I'm not a huge fan of the way that he's using a bolt winch for it, but will that work? I mean, the bolt winches oftentimes have a 500 or 1,000 pound. I mean, at 1,000 pounds, it likely has a much higher braking strength of the cable, but as long as you're winching it and then adding the safety pin in so if the winch cable breaks that it's not going to collapse. But I'm telling you, in the event that with the design he had, if that cable were to break for any reason and he thinks that that safety catch on that thin wall tube is going to stop it, there ain't a hope and a prayer, because when this drops and hits that shock load to this arm, the way he had it, it's just going to collapse it. So again, not a good idea. Now, beyond that, using grade 8 bolts to hold everything together is by far better peace of mind than them cheap chrome grade 5 bolts. I mean, end of the world? No, but let's be honest here, guys. How much is your life worth? $15 in better bolts? Mine is. Maybe yours isn't to you, but to me, that's a ridiculous oversight. Beyond that, just a simple stress testing of the design is imperative, in my opinion. And by stress testing, again, I don't mean just putting a car on it and say, oh, it didn't fall, we're good. I would load up each arm with 2,000 to 3,000 pounds, probably 3,000 pounds, get your feet out of the way of the weight, however it is you can get that much weight on it, and then push it around a little bit and at least like observe if there's like flexing in the steel, if there's cracks developing in welds, etc. Because any of that is indications that there's going to be problems, you know. Now, from a realistic standpoint, is this something that I think the average person should build? I'm going to be honest with you guys, no. And the reason is that to make strong welds on something like this that are durable takes skill. And it's not that I don't think you guys have the skill necessary. I mean, to be honest, you're here watching videos like this to learn to get better. So you guys are in the category of people that eventually could weld something like this together and have it last. It's just if your welds are not on point, good penetration, and you know what you're doing, you really don't have any business making something like this. And I'm telling you, from my perspective, and I've done sketchy stuff, I'm confident I could build something like this and have it last, but I wouldn't be relying on the weld strength. I'd be relying on the engineering more than the weld strength to hold the crap together. And that's why, you know, if you're so on welding, don't attempt to build something like this. But the great news is that with significant practice, dialing in your welds, doing some cut and etches, bend testing stuff, breaking stuff, no doubt most people could achieve the skill necessary to build something like this safe. But again, it's not just from a welding perspective. You have to have a thought process as to what you're doing. Like, I could lay down some fucking TIG welds on this that that are unbelievably perfect, and it won't matter in the least if the engineering of it is piss poor, if you get what I'm saying. Anyways, I think I spoke enough about this. Let's go to conclusion. So I know I went on a little bit of a rant for part of this, blame it that I'm sick, whatever, but stuff like this comes up fairly often, and I know a lot of you guys have been asking me about, like, how strong is an individual weld, how much weld do you really need to have, all of that stuff. And the hardest part I have in answering that is that the answer always is, well, it depends. And this is probably the best example of something I've seen lately where we can show that it's not just the strength of the welds that are the serious concern. And that's why I'm somewhat hesitant to just respond to questions like that, because in the case of this, a weld on this right here without this bracing, no matter how much weld you put on there, it might not be strong enough to hold this thing together that guy's made. And that's why it's so important to understand what you're doing. And that's also why in the future, I'm actually going to tackle doing projects with some more liability to where you guys get a better understanding of both the engineering side of it as well as what is considered like too poor of a weld for something. And I think the answer you already know on the weld section is the weld needs to be free of any defects visibly to be considered even remotely good. But the reality is less than perfect welds oftentimes hold things together all the time. I mean, I've done bend testing, like even this, there's a huge lack of fusion right at the start of this, and this didn't fail. So there is leeway on that, but we should all strive to make the best welds, and we should strive to do some kind of thought process before we just glue things together where serious liability. And it's pretty easy to determine if there's liability on something. Does it support weight above somebody's head? Does it support weight in general? Does it have to hold extremely heavy loads? Is it on some thick steel that's going to see a lot of stress? All of those things. Like if you're building something and that you use your brain to determine, at least on face value, if there's more to what you're looking at than what it first appears. And the last thing I'm going to say regarding all of this is that you have to be honest with yourself. Part of learning to weld, it's called the overconfidence time period. And that's where you know a fair amount of what you're doing and you're kind of confident and you feel that you can handle any kind of project and you know what you're doing. And that happens, it happened to me for a long time. And it wasn't until I really got into more of the engineering and having to fix problems and having stuff I made fail that I really realized there's far more to it than just confidence. And there's always something you probably overlooked, misunderstood, etc., and it could play a role. So the key with stuff like this is do not be overconfident. Like just because you put a couple welds that look decent on something doesn't mean it won't fail. So be more conservative without a doubt. And it's okay if you feel that your ability to weld something is not good enough. It's okay to get somebody else involved to weld it for you. I'm not joking when I say that I have had competent welders out there, guys who are good with stick and steel, come to me for welding stuff like stainless and Inconel and titanium and all this other stuff, because they know that they don't possess the skill to do the job that's required, especially like another one would be aluminum. And there's nothing wrong with coming to that conclusion and seeking advice or help from other people. There's nothing at all. I mean, I have actually, for certain things, especially like I'm going to be doing videos with spray arc, I'm going to be reaching out to guys I know that do more of it to come into the shop and work with me on it, because I don't do that much of it. And to get good at something, you have to have experience with it. And this is one of those things where if you don't have any experience engineering stuff like this or making decent welds out of position, you probably don't want to tackle this on your own. At least get someone else more skilled or a second opinion on it before you go and do stuff like this. It's there's nothing to gain by making something that's going to hurt someone. So anyways, with that said, If you got any comments, questions, thoughts on any of this, feel free to share it. This is something we can all talk about and learn from for sure. And if you felt that the original design was sketchy, or you feel that you could design it a little different than what I did, again, share your thoughts on that. We can only learn and collectively grow with mistakes like this. So with that said, thanks for sticking around for the video. Until next time.